Black hole is the strangest thing in the whole universe. They don't seem to make any sense at all. Where do they came from? What happens if you fall into one? How black holes are formed? Black hole is cosmic body of extremely intense gravity from which nothing, not even light, can escape. A black hole can be formed by the death of a massive star. When such a star has exhausted the internal thermonuclear fuels in its core at the end of its life, the core becomes unstable and gravitationally collapses inward upon itself, and the star's outer layers are blown away. The crushing weight of constituent matter falling in from all sides compresses the dying star to a point of zero volume and infinite density called the singularity as the star dies, in a supernova explosion. This produces either a neutron star, or if the star is massive enough, the entire mass of the core collapses into a black hole. If you looked at a black hole, what you'd really be seeing is the event horizon. Anything that crosses the event horizon needs to be traveling faster than the speed of light to escape. In other words, it's impossible. So we just see a black sphere, reflecting nothing. But if the event horizon is the black part, what is the whole part of the black hole? The singularity. A gravitational singularity, space-time singularity, or simply singularity is a condition in which gravity is so intense that space-time itself breaks down catastrophically. As such, a singularity is by definition no longer part of the regular space-time and cannot be determined by where or when. The idea of an object in space so massive and dense that light could not escape it has been around for centuries. Most famously, black holes were predicted by Einstein's theory of general relativity, which showed that when a massive star dies, it leaves behind a small, dense remnant core. If the core's mass is more than about 3 times the mass of the Sun, the equation showed, the force of gravity overwhelms all other forces and produces a black hole. Black holes usually cannot be observed directly on account of both their small size and the fact that they emit no light. Because of that, scientists can't directly observe black holes with telescopes that detect X-rays, light, or other forms of electromagnetic radiation. We can, however, infer the presence of black holes and study them by detecting their effect on other matter nearby. If a black hole passes through a cloud of interstellar matter, for example, it will draw matter inward in a process known as accretion. A similar process can occur if a normal star passes close to a black hole. In this case, the black hole can tear the star apart as it pulls it toward itself. As the attracted matter accelerates and heats up, it emits X-rays that radiate into space. Supermassive black hole, Sagittarius A Asterisk, exists at the center of the Milky Way galaxy. Observations of stars orbiting the position of Sagittarius A Asterisk demonstrate the presence of a black hole with a mass equivalent to more than 4 million suns. Supermassive black holes have been detected in other galaxies as well. In 2017, the Event Horizon Telescope obtained an image of the supermassive black hole at the center of the M87 galaxy. That black hole has a mass equal to 6.5 billion suns but is only 38 billion kilometers across. It was the first black hole to be imaged directly. The existence of even larger black holes, each with a mass equal to 10 billion suns, can be inferred from the energetic effects on gas swirling at extremely high velocities around the center of NGC 3842 and NGC 4889, galaxies near the Milky Way. The existence of another kind of non-stellar black hole was proposed by the British astrophysicist Stephen Hawking. According to Hawking's theory, numerous tiny primordial black holes, possibly with a mass equal to or less than that of an asteroid, might have been created during the Big Bang, a state of extremely high temperatures and density in which the universe originated 13.8 billion years ago. These so-called mini black holes, like the more massive variety, lose mass over time through Hawking radiation and disappear. If certain theories of the universe that require extra dimensions are correct, the Large Hadron Collider could produce significant numbers of mini black holes. If we were to swap the Sun for an equally massive black hole, nothing much would change for Earth. Except that we would freeze to death, of course. What would happen to you if you fell into a black hole? The experience of time is different around black holes. From the outside, you seem to slow down as you approach the event horizon. So time passes slower for you. At some point, you would appear to freeze in time, slowly turn red, and disappear. While from your perspective, you can watch the rest of the universe in fast forward. Kind of like seeing into the future. Right now, we don't know what happens next. But we think it could be one of two things. 1. You die a quick death. A black hole curves space so much that once you cross the event horizon, there is only one possible direction. You can take this literally inside the event horizon. You can only go in one direction. It's like being in a really tight alley that closes behind you after each step. The mass of a black hole is so concentrated. At some point, even tiny distances of a few centimeters would means that gravity acts with millions of times more force on different parts of your body. Your cells get torn apart as your body stretches more and more, until you are a hot stream of plasma, 1 atom wide. 2. You die a very quick death. Very soon after you cross the event horizon, you would hit a firewall and be terminated in an instant. Neither of these options are particularly pleasant. How soon you would die depends on the mass of the black hole. A smaller black hole would kill you before you even enter its event horizon, while you probably could travel inside a supersized massive black hole for quite a while. Thank you so much for watching video till here patiently. I hope you have gained something new about black hole from this video. We are right now in growing phase, so don't forget to like, subscribe our channel and share this video. Your subscription and like will motivate us a lot. Stay blessed and see you next time.